Hey, so welcome to day 5 of Advent of Code. I started a little early today, so we can talk over, both finish talking about how day 3 went, and then day 4, which, was my first bad day of the event. So, if you're not interested in that, just skip ahead 15 minutes and we'll start doing day 5. So let's see, going back to day 3, um, never really got to talk about. So I did this cut and paste code reuse right here. I copied that code down here, and the only difference is that this one is a 0 and this 0 is a 1, right? Now, obviously, the engineering-y thing to do is to write a function that kind of takes a parameter that tells you which one of those two things you're going to do, and then you have to have some logic to choose between them. You can do that. I think the main advantage of doing that, if you write a function, then you have to actually think through what the semantics to that function are. And that was part of what I was getting wrong here, is I didn't really think through exactly what the semantics of these code blocks are. So that would probably be the main thing I'd get out of it, turning it into a function. And then finally on day 3, I futzed with these boundary conditions here, right? There's over 2, off by 1 error, greater than or equal to, or versus greater than, yada yada. Futzing is kind of fine, but it probably would have been better for me to actually just take the 30 seconds it takes to write down exactly, what the data should be and what I would want in each of the boundary cases. Because when I read the problem, I wasn't even thinking that there was a boundary worth considering in there. Anyway, the other thing that became apparent in day 3, because it took a half hour to solve that, the raw video that I'm recording here was 10 gigs, and it took 13 hours to upload that to YouTube. I have uploaded much faster than that from my connection, so I don't know whether that's YouTube that's capping it or it's just the combination of me and YouTube, but that is excessive because, the day after, it was a whole hour, so I wouldn't have even gotten it up before the next day happened. So I've got to encode locally, and we'll skip ahead. Day 4, I actually exported it at 480p, I think, and that was not a good enough resolution. The text was just readable, but very fuzzy, so either 720 or 1080 seems appropriate. That's still quite a big file, and it still takes a really long time to upload to YouTube, but yeah. And also, one of the reasons it took so long to upload to YouTube is because I was storing the original in a place on my local machine that backed it up to iCloud, and so I guess I was sending the data up to 2 different places at the same time all day after I took the video. So, anyway, let's move on to day 4, because that, as I say, that's the first day that really didn't go well. So, we can get rid of day 3 here. So, day 4. What did we do? I spent a little time at the beginning. It was actually a note down here. It was I took 20 minutes just to parse the input. I think a lot of that is because I was trying to talk it through instead of just doing it. But even so, this I still think is the main complaint about using Swift, and I'm not sure how much is Swift and how much is just me not being particularly good at this kind of programming in Swift, because in Python, I feel like I would be able to parse this data in much less time in Python for whatever reason. And one of these things is I always forget the string split function. It drops, by default, empty subsequences, and you have to pass a special parameter. So that's something to remind myself of, because I didn't realize when I started yesterday. I don't think my library has a split function that just coalesces all the white space. I think that's the default in Python, and that is often the way you want to split things. Oh, look, we need a space there. Okay. I also realized when we parsed our bingo cards, if you remember, we got into this problem because all the numbers were kind of aligned in columns, and as a result, there were extra spaces. So just splitting on space didn't work because then we'd get spaces that got split out between those things. If it were empty things between the spaces, then the omitting empty subsequences would have gotten rid of it, but I think it gave us spaces between that, and so we wrote this code to ignore strings we got that were these kind of extra space crap things. Upon reflection, if things are being aligned in columns, that means we could have actually, instead of trying to use split at all, we could have just taken 5 different position ranges of the string and then intified those, and that would have worked. I don't think it's a big deal in this case, but that's a technique that might be useful, at some point in the rest of the month. So that's worth keeping in mind. Okay, so now let's talk about the big issue. So I had a bug in my code, which happens, right? The real issue: how was the debugging strategy to go about finding it? I watched my video. I wouldn't say debugging went well, but it wasn't terrible. Immediately it wasn't working, and I threw out 4 different ideas for where the bug might have been coming from. One of them was right, and I kind of went through the other 3 and moderately quickly did some tests to demonstrate the other 3 weren't the case. So that seems to me like the right way to do debugging. But the correct theory I kept putting off digging into just because it was the hardest one to investigate. And I think being aware of your biases in that respect is probably helpful, because I could have realized I was investing my time in less likely theories than the one that turned out to be the case. A while into the debugging, I was actually logging the data that would have demonstrated exactly what the problem is. Because I was saying, when we get a match, particularly I only put this in if the matches are a column, tell us which column the problem is. And I did that for every card that got solved. And if I had taken a bit better look at that output, I would have realized that I only ever matched on column 0. Right? I never matched on any other column, and that was exactly the problem, is I was only ever checking the first column in the first row. So I was capturing the data, and just reading the logs a little more carefully for anything suspicious would have told me exactly what the issue was, right? And I guess there's just the psychological thing of debugging. I mean, it had been a long day for unrelated reasons yesterday, and I was thinking at one point, it's just an event. I'm doing it for fun, so maybe I should just go to bed and tackle it in the morning. I'm not saying that was it was good that I didn't do that or what, but you can kind of see that in the video. And also, throughout my career, a substantial portion of the time I spend debugging is really just kind of staring at the screen and cursing the injustice of life. That, I'm not saying it works for me, but it's part of my process. So I don't know if that makes you feel less alone or not. Anyway, but I do think, it was clearly frustrating at the time, but this experience, this is actually what I like about Advent of Code. The main thing is, when you're working in industry, you get very few chances to build an entire something from beginning to end, write it and debug it and see it work, and then move on and be able to turn your back on it. That cycle can take, 6 months at the minimum, and years is common. So I actually quite like that, I had my terrible debugging thing, and it was only half an hour. It wasn't, weeks of my life wasted. So I genuinely enjoy that about Advent of Code. Um, and also, this was the first puzzle. The first 3 days were completely trivial, and I wouldn't say that the fourth day the logic was all that complicated. Like, I never had any real questions in my mind about what algorithms I wanted to use. But it was just non-trivial enough to be a little bit of fun. I felt I had actually built something, the stupid little bingo game, by the end. And again, that's part of what I really like about Advent of Code. So, so let's actually talk about my approach itself. So what I did, I spent the whole time building all these blocks, right? And then I wrote a function that just tests whether, given a particular set of numbers that have been called, whether a board wins. And so every time a number is called, I updated my set, and I checked every single board whether I won. There's an argument that that's not a terribly efficient way to do it. The complexity is something like, the number of numbers that have to be called before someone wins, which is meaningful. Like, that number can vary. We'll talk about that a little bit more. Multiply that by the number of boards, and then effectively multiply that by the size of each board. Now, just a quick skim of the data demonstrated that there were only, on the order of dozens of boards, and obviously each board was only 25 cells. And we knew that we would find winners within, I think 42 was the first thing. I think it was less, actually, when I got the code right in the end. But, again, only dozens of numbers need to be called. If we were instead picking numbers from a much larger number space, not just 1 to 100 or whatever this particular problem was doing, but, 1 to a billion, then you potentially would have to call a lot more numbers, millions and millions of numbers before somebody won. And you can imagine, well, okay, so if that number could get big, and you can also imagine getting thousands, tens of thousands of boards in input. It's not going to happen in Advent of Code because his servers aren't going to want to send you, huge numbers of these things. But we might change our algorithm if either, particularly both of those numbers, were truly large. So I think in that case, we wouldn't want to just check every single board for every single number. But instead, maybe for every number that's called, again, if it's a very large number space, it will probably be called on relatively few boards, and the only boards that we need to recheck for a win are the ones that include that number. So my instinct was just, we could have a dictionary that goes from the numbers called, and we can actually set up the rows and columns that contain that number, and those rows and columns can in turn point to the board. And so if the row and column is a winner, then we go to the board that it's a winner on, and we can compute the score or whatever, right? So we would turn boards into a class, because that's how you get pointers in Swift, is you make classes, and then you could just say that our main data structure would be this, the number called to an array of integers that would be a row or a column, and a board, which again is a pointer to this thing. An even more sophisticated thing that I'm sure the functional programmers kind of like would be to, instead of a board here, you can actually throw a function in there, because the only reason you need the board is so you can compute the scoring function. So you can just throw the scoring function into that and merely call it. There's not really much in the difference between the two of them. That's really more an issue about engineering, how you structure your code. We still have a little bit of time. And if the boards themselves were enormous, then I guess this array of integers might be a little painful, not just to traverse, but if you were like plucking numbers out of that so that you knew when you got down to none left. In that case, you could use a set, which is asymptotically efficient for doing that, but Set is like orders of magnitude slower than an array when an array is small. Even for things like deleting from the front, which everyone says is amazingly slow in an array. I mean, it's amazingly slow, but if you're just moving like 5 machine words, it's not a big deal, right? And okay, well, looks like we're ready for day 5. So let's get rid of this and that and save that and see where day 5 takes us. Okay, so this is what our input is going to look like. So, I keep doing that. Let's... Okay, so we are going to split on... we might as well just copy it actually, right? Lines. Split on that. And then for the data, now I don't actually know what I'm doing with this, so we're probably going to read farther. Whoa, what's that? Sorry. So we're probably going to read farther before we actually finish our little parsing thing, so I know what data structure I want to build. But this is the essence of our parsing, right? So let's just say yeah, blah, blah, blah. And probably XY. So it's going to be something like that, right? Actually, I don't know. Can you declare variables like that inside tuples? I don't know. It's yelling at us. Yeah, maybe that's the syntax. Anyway, we'll figure it out, and we're going to have to do something like that for D1. But anyway, so that's all our data. And how much do we have? Not all that much. Okay, so what are we doing with this data? Okay, so we want to find where these lines overlap. Consider only horizontal and vertical. I guess we're going to do something more complicated next time around. Okay, start X, start Y. And then do we need to intify these things though, don't we? So we actually want split map. Okay, let's see if any of this compiles. Those warnings are all fine because we just haven't added our code yet. Okay, so set of, can you have a set of tuples? I remember this being an issue last year. I'm wondering if Swift is any better as a language. It is not. So we're just going to use arrays that all have 2 elements because those are hashable, so you can put them in sets. So we're going to say the first element is X and the second is Y. Are we just down to warnings? Yeah. Yes, we are just down to warnings. Okay. So now, let's do vertical lines. Star x equals index. Then 4 and start y. I'm worried these might be in the wrong order, and I don't remember whether you can do misordered ranges in Swift. So, so equals star x y. If I forget if insert has a return value that could have used for that contains, but it doesn't really matter. But it would be more elegant code if I used it, if that exists. So let's see if this code compiles once we move our output declaration a little higher. Right. Let's see if this compiles. No. What's the problem here? Range requirement. Ah, yes. Okay, fair enough. So, and then does that work? Okay. So, but that was only the vertical lines, so now we just need to do this. We're going to use cut and paste reuse, and we took our tip of making sure that one version works before doing a second. So, again, I would know how to do this a lot faster in Vim, but no real engineering project has actually been held up because the programmers couldn't type fast enough. That's not a thing. So what were we doing? Number of points were at least 2 lines. So I'm worried that we might be multiply counting this stuff. Crap. And if that's the case, then if that's the case, okay, then let's make another one. There are lots of different ways to do this, but we'll just keep the coordinates that have overlaps, right? So if instead of doing playing with output, we're gonna say, right, and then we're just gonna count the number of overlaps. Okay, so what did we get before? 4782, 4655. So there were some multiple overlaps. So I think this is now our correct answer. Yeah, okay. 637, so we're doing better. Okay, part 2. Diagonal. So 45-degree lines, that's fine. Okay, so now we just have to add logic for... actually, can we... okay, so now we need to... actually, let's just say if... begin. No. I can't decide how I'm going to do this. Let begin x be the minimum of start x and x. Let finish x. So we got to keep track of which variables we're doing here. Okay. Okay, let's see if our assertions fire. Oh, wait, what? Assert. That, I thought I fixed that typo. No. Okay, so this is all good. So now, so we're just going to add that to both of these things. And we will steal this logic equals this is supposed to be I. Everyone knows I is the only appropriate variable for a loop. Yeah, I think that's a pretty reasonable thing. So we should have more overlaps than the 46, 45 we had before. Ooh, that's a lot more. I guess there are a lot of diagonal lines. Oh. Or I did something wrong. The number of points for at least there is still anywhere in the diagram. This is still with a 2 or larger. No, a total of 12 points. Okay. How many points do at least 2 large over? Okay. So something about our new logic is not right. For I and that. Begin. One, two, three. Less than 0 fx. I think that's the right thing. Or should it include? Well, let's just goes up to 0. Yeah, okay. Oh, sigh. Oh no. Is today going to be another miserable day? Begin y starts to 0. So if it's 3 minus 1, 1, 2, 3. So I think it is. I think that's actually what we want. Because in their example, 1, 1, 3, 3. 3 minus 1 is 2. 1 plus 2 is 3. So I think that's the right range statement. 0, 1, 2. Begin x. Oh, but diagonals don't always, that only has one direction of diagonal, isn't it? Yeah, so hang on. So diagonals can go down to the right, right, up and to the right. How do we tell the difference between those two? Yeah, so so this is all wrong because I'm actually, by doing these two things independently, I'm losing information, aren't I? Ooh, that's a bit nasty. So, um, oh, I'm losing places on my leaderboards. um, so, okay, we know exactly what the bug is. Should we do two different cases for the two different directions of diagonals, or what? Um, okay, let's say if if oh, I'm getting flustered. So what do we do? If the signs are going the direction, so start x, start y, end x, end y. If uh, if start x minus end x equals start y minus end y, then we'll do one thing. Else start x minus end x equals negative start y minus end y. So I think those are the two. Oh, there you go. So I think that separates out the two kinds of diagonals. Let's see if that triggers any assertions. Oh. I can't even type. Okay, that doesn't trigger any assertions. So now we just need to put the logic in here. So start x minus. So I think this is actually the correct logic for that, right? But in this case, I'm actually, I don't know. It's something like this. It's very similar to this, is what we're doing, but just throwing numbers in here is, yeah, let's think it through. Okay, so, in the first case, they're both going down together. up together. So we start with, oh no, what it is we want to start at the smaller x, but the higher y. Right? And then we want to smaller x but higher y. Then we want to add to x and subtract from y. That's what we're doing. Okay. Okay, 3 seconds to wait. Let's... Oh no! Now I have 5 minutes to... I thought I worked this out. What's wrong here? Oh, because it's not begin and end, it's F. F. I told myself that was going to be a thing. Oh, so not 1542, 2476. Are we sure that's not any of the answers we've given before? 2476. Yeah. Now that's quite a big number. I've guessed incorrectly 4 times. So 1, 2, 3. Yeah, okay. So, well, this is what happens when you flail. And how many points do at least 2 lines overlap? So I think we have this, but we probably got 4 minutes to wait until we can plug it in again. Yeah, we do. So let's just think this through. So what have I done? I've separated out the 2 cases. I'll show you my brilliant picture. Yes, that is the diagram, and that's why billion-dollar companies have whiteboards. In one case, can I do this? In one case, since this is increasing y, and this is increasing x, because we're underwater, obviously, right? So, in the simple case, then this point, both the x and the y in this point are less than both the x and the y of this point. So in that case, we just start there and we add 1 to each of them incrementally until we reach the second point, right? In this case, however, the x of our starting point is less than the x of our ending point, but the y of our starting point is greater than the y of our ending point, right? So we are going to, let's make sure I have this right. So we're going to start at the smaller x and the bigger y, right? Bx and fy. And we are going to add to x incrementally and subtract from y incrementally until we reach that final point there, right? So, given that that's the case, how long do we have to wait? 2 minutes left. What else do we want to reflect on while we wait? The parsing was fairly easy today, and I think that all went well. We know the first 2. We just talked through these diagonals, and my inequalities I still think are right, but of course we haven't completely verified that those are right. So 1 to 3, I did that. If it's 1, 1 to 3, 3, you subtract them and you get 2, and you have to add 0, 1, and 2 to get to your final point. Yeah, it seems right to me. Bx and fy. Our variable names, that's what has cost us this extra 5 minutes, really, is the variable names. And so that's something to learn from, I guess. We all know naming your variables well matters, and it's one of those things. 53 seconds left. So I think we did substantially worse on the second part of this. I'm fairly satisfied with how quickly I did the first part. The second part definitely could have done more quickly. Um, it is what it is. 24 seconds. And I'm going to be upset. Does it stay 5 minutes if I get this one wrong, or does it go up again? I've forgotten. There was one year when I really did plug in a whole bunch of answers. I think that was in 2019, and I got to quite a high timeout. Because that was one that involved a lot of number theory. What? That's not right either? What? Oh, dear. Oh, my. Well, okay. Drastic action is called for now. So, what is our puzzle input? So we have, it goes up to 1,000. 1,000 is a kind of a big number. I mean, we can visualize 1,000 by 1,000, I guess, and then look at it, right? Let's see how that goes. Do you want to visualize 1,000 by 1,000? How did we get this wrong? How did we get this wrong? I was sure. Pause. Final y. Bigger. Well, x. Bigger. Final x. What did I do wrong? Okay. Um, I'm sad. I'm sad that we screwed this up. Um, what should we do? This is what I'm spending my time on now. No, let's just print S. I mean, it's going to be super ugly what we print because we're not really going to be able to see it. Let's actually send it to output, and then we can put it in something that we can visualize a lot better. Actually, let's visualize the intersections as well. Okay, so that works. What do we have? We are seeing overlaps in the right places as far as I'm seeing. See, those exclamation points are showing up where they should. Those are events that actually strictly overlap with each other, right? I'm not getting... This isn't showing me anything we've done wrong so far. These are all looking like reasonable lines. Holy crap. What did we do wrong here? What did we do wrong? I'm just following this. Like this one is... Yeah, but it does end, so I guess those... See, I'm looking at one line that's just exclamation points the entire diagonal, but it looks like there are just two diagonal lines that cross each other. Well, okay, that doesn't prove we're actually drawing the diagonal lines correctly. Oh, sorry, and I've hidden my face, and I'm not supposed to do that. So let's think this through again, because it's clearly these diagonals, right? So if starting x minus ending x equals starting y minus ending y, that means that then final, okay, final minus begin. I can't believe I've done it 2 days in a row. I've just done something stupid here. God. So we're starting at the smaller x and the smaller y. So let's search. Starting y or x dy equals ending x ending y, right? Oh, BBEdit is very clever about updating these things. Okay. Okay, so min max, min max. Plus smaller and they get bigger. Okay. Min max, min max. Yes. So smaller x added. Final y gets subtracted. How am I wrong? What am I what This is where I stare and curse the injustice of the world. Beginning x. So that's the beginning x. Final y. I don't get it. Not you. Not you. Come on. I really don't get it. Oh. 20476. That's what we just plugged in. What are these numbers? Yeah, okay. It's all reasonable data. Actually, let's just make sure that we got it all. Head 976.35, 24.97. Yep. 54. Oh, come on. Not you. You. 154, 131, 154, 210. What? Start X, start Y, and X, and Y. let's do this example. 9, 7 to 7, 9, right? So we say start x, start is 9, 7, and end is 7, 9. So start x minus end x is 2, and start y minus end y is negative 2. So that's not the case, but this is, so we end up here. So begin x is 7. Finish x is 9. Begin y is 7. Finish y is 9. All makes sense. Okay, for I in 0, 0, dot, dot, less than 9 minus 7 is 2. Oh, yeah, really? I proved this wrong to myself multiple times. For in 0, dot, dot, less than, finish x, so that would be 0 and 1, as opposed to 0, 1, 2. Well, I'll have to watch the video and see how I talked myself into it being less than, because I did that multiple times, and I guess I did it wrong every one of those times. I mean, this is very close to our previous number. Doesn't that count? Being pretty close? Yeah, okay. So, let's see just how much that cost me there. Day 5, we took 43 minutes this time. Went from 6:37 to 34:44 because we got that range wrong. Oh well. Anyway, I enjoyed that puzzle as well. So anyway, I'll see you tomorrow to do another one. Bye.